There you go. All right, so can you calculate the area of this rectangle and the perimeter of this rectangle for me? Okay. The perimeter was 12. Good. So we added up all our sides. 4 plus 4 plus 2 plus 2 is 12. And our area is 8. Length times width, 4 times 2 equals 8. All right, now let's do another one. But let's make it twice as big. So in this case, it is 8 times 4. What's the area of that? What's the perimeter of that? So area is 32, length times width, 8 times 4, so the area is 32, very good. My perimeter is 24. Fine. So let's take a look here. Is there a link we see between these numbers and these numbers? Is there a link between the area of the purple one and the blue one? And is there some kind of pattern? This is like just in looking at it. Do you think there's a pattern between the area of the perimeter, not the area, the perimeter of those two?
The perimeter is doubled.
So we're going to predict right now. If we double the shape. Oh my God, what happened there? So if we double the shape, the perimeter is going to be doubled.
And the area is times 4.
And we're going to quadruple the area. Okay, or times 4. And this is going to be times 2. So let's do another one. Let's go with another one. Let's see if this holds. So if we're doing this, we're going to go 16 on this side and 8 on this side. So our prediction right now is we're going to double this. So our prediction is our perimeter will be 48. And our prediction is going to be our area is going to be, we're going to times that by 4, 128. That's our prediction, do we? Okay. So what is our actual perimeter and area of that? Was our prediction correct, or was our prediction off a little bit?
Our perimeter prediction is correct.
So our perimeter prediction was correct. So 2 times 16 plus 8 equals 48. Okay, so this one's correct so far.
Boom. And the area is correct as well.
Area, length times width. So 16 times 8 equals 128. Wonder if this works with a different shape. What shape do we want to do? A triangle. I don't know if it'll work in a circle. Let's do a triangle. So this is our prediction right now. Our hypothesis is this. Let's do a triangle. Uh-oh, I gotta do some math now. Shoot. Why did I pick a triangle? So let's say the base is this side is 5, this side is 5. This whole bottom is 6. Can someone tell me how I'd find the height of this? How would I find this measurement right here? Do.
Can I just tell you what the height? Go ahead, Evelyn.
Oh, who was going? Evelyn Rebid, say something?
I was not.
You were not? Okay.
I was not.
Well, Ella, tell me how we found the height, not what the height is.
Oh, well, basically, 5 times 5 equals 25. 6 times 6, 36. And 25 plus 36 is 121. And 121 square root is 11, so the height's 11. I think that's right. I don't really know if I square rooted 121 properly, but I just did it in my head, so I'm pretty sure it's 11.
Nope. So what she did was she made a triangle out of this, right? And went from there.
Yeah, and then 5 times 5 is 25, so then it's 25 for the one that's the hypotenuse thing.
How long is this side though?
So, it's 3.
3.
So,
and slow down.
25 plus 3 is 28. Oh.
Which one is your hypotenuse?
The one that you're making a square on, a rectangle on right now.
This one, right?
Oh, so you have to minus it. So 25 minus 3 is 22, right?
Slow down. 3 times 3 is?
Oh, 9. 25 minus 9. I don't really know what 25 minus 9 is.
Minus 10, then add 1.
16, so it's 4.
There we go. So now the height of this one is 4. Oops, why did I say 4 and write 5? All right. So all we had to do was a little sum of squares there, right? We had to recognize we have a triangle. We have a nice right angle triangle. So what's our perimeter of this one? What's our perimeter and what's our area? My formula for area is base times height divided by 2. Oh, I gotta run outside for 2 seconds. I'll be right back. You guys get your answer for me. No, he didn't ring the doorbell. Okay, I'm back. Sorry, I had to grab something from someone was dropping off something at the door. All right. What were our calculations here? Who wants to give me my perimeter and who wants to give me my area? There we go. I have a bunch of lumps on a log there today. Not much going on. My perimeter was 16. Good. So just gonna add those numbers together. And my area is area was 12. I don't think so. Oh, yes, it is 12. No, yes, it is 12. Yeah. Sorry. 6 times 4 divided by 2. 24 divided by 2 equals 12. Perfect. So let's see if this holds now, our prediction. So if we do another one, now remember these aren't the scale. So I'm going to put a, oops. I'm going to put a 10 on this side, a 10, a 10, and a 12. And we got to figure out our height. I don't think it's going to be a pretty number. It's going to be 100 in that box. The 6, so 36 in this box. Well, it's actually going to be a pretty number. 100 minus 36 is 64. And the square root of 64 is 8. All right, so our prediction is our perimeter is going to double and our area is going to be quadrupled. Does it hold true? So the perimeter is 32. So these two are double. So this checks out again. And what's our area going to be? Our area is 48, so we have 8 times 12 divided by 2, which equals, what was that, 40, 92, 96 divided by 2, which equals 48. And 12 times 4, so if we quadruple it, equals 48. So we figured out what happens when you double area. What happens if you triple it? Is there a pattern that happens if you triple it? I've never figured this out, so I'm just going. So if we triple the original one, let's do this. Let's do a 1 by 1 box. We'll do 3 sets of boxes here. So 1 by 1, if we triple it, it's going to be 3 by 3. And then if we triple that one again, it's going to be a 9 by 9. So let's someone figure out the area and perimeter for this one. Someone else do the 3 by 3 one. And then a last person do the 9 by 9 one. When you have your answer there, write it in chat. I'll do this one. The area for this one is going to be 1, and the perimeter is going to be 4. Let's work on the middle one now. We are a slow bunch today. For the last one, With our last one, it was 81 and 36. I have it for the middle one. Who's got the middle one done here? Nine and 12. All right. So first of all, let's look at perimeter. What's our pattern here? What's our pattern between these numbers? Times 3. Very good. Now what's our pattern up top? Good. Times 9. Here's a weird thing. What also equals 9? Uh, 3 squared, yeah. 3 to the power 2, right? Well, if you look down here, we quadrupled. What squared equals 4? 2. So if we double it, we get the square of it, right? If we triple it, we put a 3 in there, 3 squared. Now, I bet you can make a prediction. If I took this square right here, that had an area of 9 and a perimeter of 12, okay, that was what? 3 by 3. And I made it 5 times bigger, right? If I made it 15 by 15, right? Our logic says we've been, oh, this would be times 15 because whatever, oh, sorry, times 5. Could you make a prediction of what? I got these mixed up. Sorry. That would be times 5, right? What would this one be times by? Thinking back, the first one was times 4. The second one we did was times 9. If we made it 5 times bigger, what do you think it would be times by here, this area? When we doubled it, it was 4. When we tripled it, it was 3. If we did it times 5, what would that be? What number would go right here? Just like we had a 9 right there. Not 40. I bet it'd be 25 times bigger. Because 2 squared was 4, we times it by 4. 3 squared was 9. So if we made it 5 times bigger, it'd be 5 squared, which is 25. So I bet the area would be, what's 9 times 25? 175. Nine times 25? Oh, it is 225. Yeah, you're right. My 225. And 15 times 15 is 225. So what good a little note could we do here? Let's make a little note for you to write down. And then I think I have good news for everyone. Okay. For two-dimensional shapes, where's my pencil? I'm going to zoom in once I get this typed in. Does that make sense, everyone? Oops. Oh, come on. For two-dimensional shapes, the perimeter goes up by the multiple you increase it by. So if you double it, the perimeter doubles. Okay. The area goes up by the multiple squared that you increase it by. So I'll make a little diagram below here. Perimeter area. So let's say the original has a perimeter of 10 and an area of, let's say, 20. If I double it, it's going to be 10. So double is 2. It'll be 10 times 2. So the new will be 20. On the bottom here, it's going to be 10 times 2 squared. Oh, sorry, not 10. My computer has been acting up today in the worst way. I even restarted it and it's still having fun. Where's what I was working on here? Which is 20 times 4, which equals 80. Okay. Now, can you guys help me out? What if I made it quadruple? What if I quadruple the size? So it's a 4 in there. Going from my original, what would my perimeter be? From the original, if I quadruple it and made it a 40 by 40 or whatever, what would my perimeter be? So area goes up by the multiple that you increase it by. Who's got a prediction for me? Is anybody out there? Or put it a D in chat if you don't understand what's going on right now. Trying to figure out why I'm not getting any answers. I'll do this one. So this one, I'm going to go 10 times the amount we're going up by is 4. So my perimeter is going to be 4. Here it's going to be 10 times 4 squared, which is going to be 20 times 16, which is, should have that in my head, 320. Okay. Thank you, Callum. Last one. I'm going to increase it by a rate of times 5. Can we work out these two answers for me, please, and thank you? Oh, sorry. Okay, you're working from 40? We'll work from this one. Work from the original. Sorry, Nathan. So start from the original. So we're multiplying it 5 times this number. So 10 times 5 up here is 50. Okay. Then down here, it's going to be the original 20 times 5 squared, which is going to be 20 times 25, which equals 500. Good. How do we get this concept for two-dimensional shapes? Out of 5. 5 is like, yeah,
So
I understand what's going on.
Mr. O, for this, all you basically do is just times 10, like to find the thing, you just times 10 by whatever you increase it by. And then for the area, you just times the thing to the power of 2. Like whatever number you're increasing it by, just to the power of 2 for everyone.
Yep.
Like say it was 10, it would just be 10 times 10, and then it'd be 20 times 10 to the power of 2.
Correct. Yep.
Okay.
He's a workout tonight sometime. I forget when.
It was so much fun.
All right. Good. I'm going to put this together. A lot of the stuff we've done, I'm going to put together. Do you guys want the good news now or the good news later at the end of class?
No.
No. All right. The good news is, and actually, I don't know if Austin will probably think this is bad news. If you're looking at my screen, there's my good news. We're not going to do EQAO for this group, for you guys. My computer like totally taking a break now. So I advocated for it. I asked for no EQAO because it wouldn't be really a good a use of time for us, but also in terms of it wouldn't be a fair evaluation of you guys as well. It's because it wouldn't be a fair evaluation for you, Rihanna. Because if you think about it, each one of our days is kind of worth 2 days. And you missed, well, that last week of December was fractured, as in we had 2 days in class. We had about half the students in class. Then we had 3 days online, right? And we actually did online class. Some people didn't, some people did, right? So that was fractured for us because like in this class, like you guys could have been there, could not have been there. People were sick and so on and so forth. And then coming in, that's in December. And then in January, we had the first 2 days you didn't have class. And then Wednesday, you didn't really have class, it was just a check-in. And then we got started again, right? Then we had class, and then class this week. So if you kind of take this day, this day, this day, this day, this day, this day, and consider like these, I had half the class here, some could work from home. So if you put those together and just roughly give it like, let's say there's 6 days where we couldn't do work. That's actually 12 days, which is actually almost 2.5 weeks of school that we missed in terms of class time. So that's kind of what I said. And with that, now going back next week, who knows next week, right? Here's our next 2 weeks, right? I want to say EQOA would have been on this day here. Who knows if in between these 2 days, what if I get COVID right here? That means this day, probably this day, maybe that day is probably a supply or something else. Now, is that a fair evaluation of your guys' skills? Not really, right? So that's my argument. And who knows, like if a kid's sick, like if you get sick in this day, right, you're going to miss this day, this day, this day, this day, right? And who knows if you can catch up, and then you're supposed to come back 2 days and write out like an all-encompassing evaluation. So that is why. Dylan, put up your hand. You can go ahead, Dylan.
What day are we coming back to school?
Monday. Unless you are a student who is choosing to stay at home. Because there's parents have been given the option to have their students stay at home. So if you stay at home, we'll probably just do hybrid class for those students. Okay?
Okay.
Excuse me. All right. So we did 2 dimensions, right? Now let's do 3 dimensions. So let's have a couple shapes here. And this is a beautifully drawn shape I did. Don't argue about my beautiful shape. Let's do 3 of these. Okay, we'll make the first one in black 2 by 2 by 2. Okay. Rihanna, did my explanation tell you why? Yeah. So we're going to figure out the volume of each of these and the surface area of each of these. And we're going to look for, see if there's a pattern as well that goes on. So our volume formula is length times width times height. In this case, they're all going to be the same. And our surface area is 2 times length times width plus width times height plus length times height. So I'll do the first one here, which is going to be 2 times 2 times 2, which is going to equal 8. This one is here going to be 2 times 2 plus 2 times 2 plus 2 times 2, which equals 4 plus 4 plus 4, which equals 12, which equals 24. Do we all put an F in chat if you follow along with what I just did there? Good. Good. So now let's double it. Let's go 4 by 4 by 4. Okay. Can you, with your paper and pencil in front of you, figure out your volume and your surface area for these two shapes? And if you want to walk through, put a W in chat and I'll walk through it with you. Do. Are we just all waiting for someone else to give the answer? Oh, we have same thing on volume of 64. Our surface area, we have a different response here. Oops, that's not a 4. 2 times 4 times 4 plus 4 times 4. Oh, I think you just forgot the, yeah, that's no problem. 4 times 4. 2 times 16 plus 16 plus 16. That's going to equal 192. All right. Okay. Let's look here first. How do you go from 8 to 64? What's a way we can go from 8 to 64? Eight times 8? Okay. So 8 squared equals 64. let's look over here then. Let's try this one. Just this, let's just do volume. If I double this again, do we have a prediction of what this number is going to be? So if we took this number and squared it, oops. One second. Hey, cube, yeah. All right. So this was a times 2, right? Oops. Can I get to the green? That was times 2. If we times it by,
Dad,
we could triple this. Yes, dear.
this goat's in a war.
Okay, I'm teaching right
And
now.
it's doing this to Grandma.
Yeah, I can't.
Nope. Can I
Okay.
say hi?
You can say hi real quick.
Can I teach your class?
No, you cannot teach my class.
Who wants me to teach your class?
Yeah.
Dad's class.
Yeah, get out of here.
Can you vote who wants me to teach the class?
No, we cannot do that.
Why?
Hmm?
Why? Please.
Okay, here we go.
Okay.
Oh, Rihanna wants you to teach the class.
Okay, that's the vote.
Okay, out of here. All right. Let's work this one out first. I want you to do this question here real quick. What's the volume of this one and what's the surface area of this one? You do not want that. You'll have a less. She'll just ask for pictures of your dogs. That's all she'll do, Austin. Oh, my computer. We have volume of 512. And what's our surface area? $384. Do we have a seconder on 384? Okay, good. Now I want to see you see a pattern between these numbers? Yeah, I think this one's wrong. 16 plus 16 plus 16 times 2, 96. All right. So who can see the pattern between these ones for surface area and for volume? So how do we go from 8 to 64 and 64 to 512? Let's look at volume first. As we go up, every time we double, what do we multiply by? Good. So we times it by 8. 8 times 8, 64. 64 times 8 is 512. So every time we double, we multiply the volume by 8. It gets 8 times bigger. Oops. Good. And for surface area, good. Does that make sense, everyone? So surface area multiplied by 4. You can go downstairs.
Not yet. I was gonna go get blood work done, but I was gonna wait till after you're done teaching.
Okay. So for example, let's go make our little chart here. If the original had a volume surface area, we'll go for a volume of 10, a surface area of 20. If we doubled it, what would my volume be and what would my surface area be? If we doubled the original, what would my new these two be? Dun, 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 dun. Dun, 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 dun. Gonna be online all day waiting. Is it a fact we're waiting for everyone to put a D in chat if you don't understand? Put a W in chat if you're just waiting for someone else to do the work. Caleb says it's going to be right. I disagree with those. I disagree with those answers. We're looking for a volume here. What do you do with the volume? It's going to be 80. 10 times 8. Okay. And what are we going to do with the surface area? Surface area is also going to be 80. We're going to times it by 4. It just happens to be both. Okay. I want to take a peek at something real quick. Let's go 1 by 1 by 1 to a 3 by 3 by 3 to a 9 by 9 by 9. So we're going to triple this time. Okay. Volume, surface area. So for this one, the volume is just going to be 1. Because 1 times 1 times 1 equals 1. Length times width times height. Okay? Our surface area of this one is going to be 2 times 1 plus 1 plus 1. It's going to be 6 if I'm not mistaken. 3 plus 3, 6. Right. You guys were all working out this one? Mr. O will do this one. Class, you figure out that one. You guys should be able to finish it before I do. Okay. 3 times 3 times 3 is 27. 9 plus 9 plus 9. 3 times 27 is what? 81. You guys done yet? This is length times width times height. 729. Good. And what's the surface area? 486. Yep. Nope. Get times it by 2. Good job, Siva. Okay, what's our multiple this time? What do you multiply for each of these? Really? Oh, I messed this one up. Good. Volume, you times by 27 each time. So if I had something that was 27 by 27 by 27, if I wanted to know the volume of that, I would take this number and times it by 27. which is some huge number such as this. It's 9 4, we're times by 9. Good. So I'm going to go back here. Let's put all our stuff together. Doubling 3D shapes. Let's do tripling 3D shapes here. What was our numbers? Our number was 27, and this was by 9. So these are the 3 things you need to write down for today. I'm going to change that to a different color so it just stands out differently. Okay. So get those 3 items written down in your sheet. Put a D in chat when you're all done writing those down, if you haven't already written them down. But have them somewhere where you can look at it, where you can pull it up. Good, good. Okay, I'm going to pop over to homework, and I'll come right back to this. So for the rest of the class, you have some Friday work here, Friday practice to work through. Okay. Don't do this one here. I don't know if we did the cylinders. I'll test if it holds. Okay. But they're pretty much the same idea, okay, as we just did. Boom, boom, boom. So, and then you have the rest of class to also finish off your culminating work and any other work you have to complete this week. So as of right now, get this logged in. You guys have the rest of the time to work by yourself. So you can stay logged in the meeting, or you can log off to the meeting. Actually, don't log off yet. I want to double check my attendance. See if anyone showed up since I last did my attendance. So then once I give you the okay, So let's see who's here. Is Delina, Lamalakai, or Nick here? No Delina. No Lamalakai. No Nick. Okay. Troy or Madison? Madison. Troy, you're here now. Okay. Vicky, I see you. And Maria, I see you now. Jacob and Kaylin. Robertson, you're here. Jacob, you're here now. Good. And Trenton, I saw you log in. And Siva, I saw you do some stuff. Okay, perfect. So as of right now, I'll write in chat. Cool. So right now, you have the following to finish. One, Friday practice. 2, Thursday assignment. And 3, you have your culminating. Okay. So those are 3 things you have to complete. Okay. I want all those things in by Sunday at midnight, but I would recommend working on them now. Okay. You can work on them and hang around the meeting, or you can work on them and be out of the meeting. It's your choice.